Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Today we learn about the coordination chemistry lecture 1. In this lecture we studied about the various terms in the coordination chemistry. So coordination chemistry is a very important type of chemistry, and in this we see the some basic terms which is used when we learn the coordination chemistry. So in this term we first see the term coordination compound. So coordination compound is a complex compound in which the number of bonds formed by the central atom or ion is greater than that is expected from the usual valency consideration. So in the coordination compounds, metal is attached by ligand. The group or ions attached to the metal by coordination bond, that is called as ligand, or that ligand is denoted by the letter capital L. So for studying the coordination compound, we take example of potassium ferrocyanide, that is K3FeCN6. So in this K3FeCN6, the usual valency of Fe is 3, but it forms 6 bonds with the Cn minus ions. So in this case, here Fe is attached by 6 Cn minus ions, and actual oxidation number of Fe is plus 3. So here the total number of ions attached is more than the oxidation number or valency of this Fe. And so this K3FeCN6 is one of the coordinate compound. Now we see second terms, complex ion. In the coordinate compound, in square bracket, certain species are shown, and that is called as complex ion. So this complex ion is charged species, and that is formed when a metal atom or ion is directly attached to a group of neutral molecules or ions, that is called as ligands. So complex ion is indicated by enclosing the formula for the ions in a square bracket. For example, that complex ions are classified into three types, that is cationic complex ion, anionic complex ion, and neutral complex. So firstly we see what is mean by cationic complex ion, and for that purpose we take one example, and from that example we get idea about that term. So we take example of CuNH3 4 bracket raised to plus 2. So in this example there is neutral ammonia molecule, and that is attached with copper plus 2 ion. So in this example, here charge on the complex ion is plus 2, and so this complex ion is called as cationic complex ion. Now we take second type of that complex ion, that is anionic complex ion. So in anionic complex ion, also we take one other example, CONO2 6 bracket raised to 3 minus. So in this example, negatively charged NO2 minus 2 ions are attached to the cobalt plus 3 ion. And in this example, here, if we see the charge on the cobalt, then that charge on the cobalt is plus 3 and total charge on the complex ion is minus. And so this complex ion is called as anionic complex ion. Now third type of complex ion, that is neutral complex. So neutral complex means on that complex there is not any charge or it is neutral. Means in that positive charge and negative charge is balanced and it is equal to 0. So we take example of CONH3 thrice Cl3. So in this example, here the negative ion by Cl minus ion as well as neutral NH3 molecule is present, and so the charge of the cobalt plus 3 ion is balanced by 3 Cl minus ions, and so this molecule is neutral molecule, and so that is called as neutral complex. Now we see the third term which is used mainly in the coordination chemistry, that is central atom. So the central atom is the metal atom generally present in the neutral coordination compounds to which two or more neutral molecules are attached. So here we take various examples. So we take first example NiCO4. So in this NiCO4 example, CO is neutral molecule, and when neutral ligand is attached with the metal, then charge on the metal is 0, means it is in the atomic state, and so such type of atom, that is called as central atom. Then second example, FeCO5. In FeCO5, 5 ligands, 5 carbonyl ligands are attached with the Fe, but CO is neutral, so oxidation state of Fe is 0, and so in this FeCO5, Fe is neutral charge, that is in the atomic state, and so that is called as central atom. Now we see the next term similar to the central atom, but it is different than the central atom, that is central ion. So central ion means in this metal ion in the complex to which two or more neutral molecules or anions are attached. Here we take one of the example, CONH3 5Cl bracket raised to 2 plus. So in this example, cobalt ion is the central ion to which NH3 molecule and Cl minus ions are attached. So when we see the charge on the cobalt, then cobalt carries plus 3 charge. It carries certain charge, and so that is in the ionic state. And so in this example, this metal is called as central ion. Now we see the one of the term, that is coordinate bond or dative bond. So in the coordination compound, bond present is called as coordinate bond. That bond is also called as dative bond. So this coordinate bond is a special type of covalent bond in which two shared electrons are contributed by only one of the two atoms linked together. So in the coordinate bond, there is a covalent bond, and in that two shared electrons are contributed by only ligands, because ligand carries lone pair of electrons, and that ligand electrons are contributed in the formation of coordinate bond. At that time, metal have electron deficient and it accept electron from the ligand. So this atom contributing the electron pair, that is known as donor atom, while the atom which accepts this electron pair, that is known as acceptor. So coordinate bond is usually shown by pointed arrow, and this pointed arrow is directed from donor atom to the acceptor atom. So this pointed arrow is directed from ligand to metal, and so such type of bond, that is shown as ligand to metal bond. One of the term coordination number, in shortly it is called as CN. So what is this coordination number? So number of ligands which are directly attached to the central metal atom or ion is known as coordination number of the complex. For understanding the concept of this coordination number, we take one simple example. From that you get idea about this coordination number. So K3 efficient 6 is one of the example. In this compound, Cn is attached to Fe and 6 Cns are attached directly to Fe. And so this Cn or coordination number of this Fe metal is 6. So we say that in K3 efficient 6, the coordination number of Fe is 6. We take one other example, K4 efficient 6. In K4 efficient 6 also, Fe is attached by 6 Cn, and so coordination number of Fe in K4 efficient 6 is also 6. In this way, we can take different examples and we can see the coordination number of that different complexes or metal. Now, in coordination compound, one other term is used, that is first coordination pair. So, what is mean by coordination pair? In that coordination pair, there are two types of pairs, that is first coordination pair and second coordination pair. So, first coordination pair means this refers to the molecules that are attached directly to the metal. For example, we take the hexaamine cobalt 3 chloride. In hexaamine cobalt 3 chloride, here the chemical formula of this hexaamine cobalt 3 chloride is CONH36Cl. In this CONH36 3 plus, that is called as first coordination pair. In this case, here cobalt is attached by 6 Cn. They are directly attached and they are close with the cobalt, while 3 Cls are attached, and that 3 Cls are at certain distance from the cobalt, and that is at second pair, that is called as second coordination pair. So we see the concept of second coordination pair. So we take the same example here, CONH3 6Cl3. In CONH3 6Cl3, NH3 is attached in the inner side, so that is called as first coordination pair, while Cl is attached in the second coordination pair. So this second coordination pair consists of molecules and ions that attached in the various ways to the first coordination pair. And in this, here CO is attached in the 6NH3, that is first coordination pair, and outside that cobalt is attached with 3 Cls, and that is in the second coordination pair. So in this way, there is two terms, first coordination pairs and second coordination pair. So when we studied any coordination compound, then at that time we have to see that which ions are present in the first coordination pair or in the second coordination pair.